All right, ladies and gentlemen, let's take a look at some area and perimeter formulas and maybe even try a couple of these out. I do kind of want you to understand where some of these formulas are coming from. Some of them we should have some past experiences from. If we know we have a rectangle, all right, a lot of these, most of them we're talking about area. Try and remember the concept of the perimeter is pretty much layman's terms, all sides added up, all of the exterior sides. The rest of these, area. Hopefully you remember area of a rectangle. Some people say length times width. A lot of times we're going to use base and height because some of these formulas build upon the other shapes, like a parallelogram. Parallelogram is kind of like a rectangle that is leaning to the side. Well, please realize that if I made a perpendicular line right there and I cut off this triangle and put it over here, we just have a rectangle, which means the same formula works. I just need the base, and the height is not this diagonal measure, but it's this vertical one here. So we still have the same formula, area is base times height. Well, a triangle builds its formula off of the same ideas. If I took an exact copy of this triangle and I picked it up and spun it upside down, I could put it right here. And we would end up, if I put those two shapes together, it's just a parallelogram. So the idea of the base, which would be from here to here, and we always want a perpendicular vertical height. Base times height would still work here, except we don't want this entire object. We only want half of it. Believe it or not, the trapezoid works in the same way. Again, a trapezoid only necessitates one pair of parallel sides, here and here. If I played the same game, I take an exact copy, pick it up, flip it upside down, and put it right next to it, we end up having another parallelogram. So this should work, but the concept of the base, all right, I would need this measure plus this one. Well, this measures the same thing up here. These are the two bases. We call this base 1 and base 2. So we need base 2. We also need base 1. We're still going to need that vertical or perpendicular height. And again, we want half. So that's why the formulas looks a little different. Area is 1/2. I need base 1 plus base 2 times height. A square, in case you didn't know, is just another same thing as a rectangle. So the formula up here still works, but just so you know, the base and the height will be the same. So sometimes you're going to see the base and height turn into S for side. So base times height would be side times side or side squared. Just be prepared to see that as well. Area of a circle, pi times the radius squared. Try not to get that confused with circumference, which was 2 times pi times radius. So it's the exact same items, just utilized differently. Okay. A sector is a portion of the circle. So let's say if I only wanted to find the area, not of the whole circle, but I want this, I still want to use the area of the circle, but I want to know, we got to find out what fraction of the circle. So we'll do however many degrees out of 360. This will give us a fraction of the circle they want. You take the fraction times the area of the whole circle, and you'll be able to come up with just the area of that one piece of pi, which is called a sector. So the same thing kind of works here for what's called arc length. Now we have what's called arc measure. So if from point A to point B, we can talk about how many degrees of the circle that is. Let's say that's like 100 degrees. All right. Well, the other concept, I'm going to sneeze. That was a good sound. It's a good one to get on a recording. But length is different than measure. Length is if I'm standing on point A and I want to walk around the circle to point B. So the length all the way around is the concept of circumference. Circumference would be the perimeter of a circle. Well, if circumference finds the perimeter of the entire circle, we only want a certain percentage. Well, the question is how many degrees? Again, we only want a certain fraction of, always means multiply in mathematics, of the circumference. And we'll try one of these out in a second so we can kind of see all that applied. Now let me zoom out just a little in case you want to get this would be a great time to get a picture with your phone so you have all those formulas in one place. This would be a good time to pause the video and do that. Otherwise, let's start applying. But try and understand, I want you to understand the application phase in high school. We can't do the simple middle school problems, all right? If I'm going to challenge you, I'm either going to hide information. It's like rectangle. I want to find the area. I got to do base times height. I got the height, but I'm missing the base. So I can either hide information from you, or I start throwing a bunch of letters in there and make this a literal equation where you have more letters in the numbers and see if that challenges you or raises the rigor. Okay, so let's start here. If I want to find the base, try and understand almost all of these shapes. All right, if we come back here, almost all of these shapes, especially if I were to draw one of the diagonals here, there is right triangles hiding in all of these shapes. There are right triangles and rectangles. If I'm using the height of the parallelogram, we create right triangles. The height in a triangle creates right triangles. Same thing in trapezoids. We could do the same thing in a square. We could have special right triangles. So you got to be prepared for all the things that we learned related to right triangles. So here, if I need the base, I have two sides. I know that's a right angle because they told me it's a rectangle. So I get all those cool things going along. So this is a Pythagorean theorem problem. A squared plus B squared equals C squared. 25 plus B squared equals 169. Move the 25 to the other side. I got B squared equals 144. Square root both sides, and my base is 12. My height is 5. 5 times 12 gives me an area of 60. Please understand, if these are meters, which are one-dimensional measurements, area is a two-dimensional concept. So the units would be meters squared. Here, I'm kind of working the idea in the opposite fashion. I already told you what the area is. Okay, well, what does each side have to be? Well, if area was found using that formula, we already know the area is 4x squared y to the fourth equals side squared. I just need to find out, well, what is the square root of this idea? The square root of 4 is 2. The square root of x squared is x, and the square root of y to the fourth is y squared. So this is going to challenge your algebraic skills, or we're going to use some of your skills to derive missing information. Here's the area of the sector problem. Now remember, the question is how many degrees out of 360 if I'm going to do area times pi r squared? Well, the amount of degrees that I want of this full circle is 60 degrees. And the radius is 12. So we're just plugging the information in. And just understand, you may be asked to leave your answer in terms of pi. You need to know what that means. It means we're going to do all the mathematical work. We're going to kind of leave pi separate from our mathematical work. All right. And the calculator can really help you a ton on these. So we have 60 divided by 360 times 12 squared, which happens to be 24. So if the answer would be 24 pi, let's say again, these are maybe the unit of feet. We're doing an area, so this would be feet squared. 24 pi feet squared. If they want us to round the value, because that's a hyper accurate, we don't have to round anything. If they want us to round the value, that's when we are going to plug in pi. So 24 pi, we can go with an inexact answer and come up, say we round it to the tens, this would be 75.4 feet squared. All right, same kind of idea, but arc length, we talked just a second ago. The question is how much of the circle times the full circumference. Well, we want 120 degrees out of 360 times 2 times pi times radius, which is 9. If we're going to leave our answer in terms of pi, again, we can do all the mathematical work. 120 divided by 360 times 2 times 9. We just leave pi out of the calculator. We have an answer of 6 pi. Or we can do everything into the calculator and get an answer. If we round it to the tenths, it would be approximately, not accurately, but approximately 18.8. And if these were inches, arc length, this is not an area idea. This would just be 6 pi inches or 18.8 inches. So you got to really know the difference between one-dimensional measurements and two-dimensional measurements. So here's just some of the ways you could be challenged in certainly a rigorous fashion compared to what you've been presented with in middle school. Okay? But stay calm. You can do all these problems. Good luck.